Hi guys, welcome back to my channel. Today we are going to discuss the topic system of linear equations. We are going to see the basics and then we are going to see what types of solutions do we get, the basics, the solution, and the methods that we use to solve the system of linear equation. So first of all, we will see what is a linear equation. As we have seen in earlier classes, a linear equation is basically an equation that has maybe one variable like this or two variables, x plus 2 is equals to 3 or x plus y is equals to 9. Both of these are linear equations, a linear equation in one variable, a linear equation in two variables. Why we say these are linear equations? Because the variables have the power 1. Okay, so this is a linear equation. Now, what is a system of linear equation? A system of linear equation is basically a set of equations in which we can have more than one equation, and more than one variable. Okay, suppose we have example number one. Okay, and there's one more thing that we can use any variable that we wish to use, x, y, z, a, b, c, x1, x2, x3, whatever. So here is an example of a system of linear equation: 2x1 plus x2 plus of 3x3 is equals to 7 minus 4x1 plus x3 is equals to 6, 7x1 minus x2 plus 4x3 is equals to 2. This is a system of linear equations. All the variables we see have the power 1. And since we have a group of equations, we say this is a linear system. Okay. And there is one more example that we can see. X plus 2y is equals to 7. X minus 3y plus z is equals to 8. We see we have two equations and three unknown variables. So this is also a system of linear equations, a linear system. So generally we can represent a system our system as a11 x1 plus a12 x2 plus up to a1n xn is equals to b1. Now we need to focus here on the subscripts. Okay, this is a11 x1, a12 x2, a1n xn is equals to b1. Similarly, a21 x1 plus a22 x2 plus up to a2n xn is equals to b2. And similarly, since we have a linear system, we have a group of equations. It might be a m1 x1 plus a m2 x2 plus up to a mn xn is equals to bm. This is a system of linear equations. Here a11, a12, a1n, a21, a22, a2n, am1, m2, mn, all these are the coefficients of these unknown variables. x1, x2 up to xn are our unknown variables, and this b1, b2 up to bm is our right hand side of the equation. So we name this system of equation as 1. We are naming it because we will use it further, okay? So using the matrix notation, this is our general system of linear equation, general system of linear equations, or we call it a linear system. Using the matrix notation, we can represent this system as Ax is equals to B, where A, X, and B all are matrices. A matrix basically represents the coefficients A11, A12 up to A1n, A21, A22 up to A2n, and so on up to AM1, AM2 up to AMN. We see here, since we have m equations here, 1, 2 up to m equations. So we have here m rows and n columns. So this is our m by n matrix A. And similarly for our matrix X, matrix X will be a matrix of unknowns. X is equals to x1, x2 up to xn. And B matrix will be of column vectors b1, b2 up to bn, bn. So now we see that this is our system of linear equations, and we use this matrix notation to represent this system of linear equations. Now we are going to see the types of the linear system. We have two types of linear system. The two types of linear system, we have Ax is equals to B. This is the short form that we are using for our general system of linear equations. And we know what is Ax and B. We have two types of linear system. The one is a homogeneous linear system. Homogeneous linear system and a non-homogeneous linear system. Non-homogeneous linear system. When this right hand side is equals to 0, when this B is equals to 0, we have the system as Ax is equals to 0. This is our homogeneous linear system. And when we have this right hand side B not equals to 0, and this is some scalar value, we have the system as Ax is equals to B. This is our non-homogeneous linear system. And then there are also some things that we should know about the homogeneous and the non-homogeneous linear system. The homogeneous linear system is always consistent. It means that always a solution exists. A solution always exists. It could be an infinite solution or it could be a unique solution. Infinite or unique, but there is always a solution. And a non-homogeneous system is, it can be consistent, can be consistent or inconsistent. It means that it might have a solution or might not have a solution. So we here draw a type of chain that we can use to see what is a linear system. Our linear system it is either consistent or inconsistent. Consistent and inconsistent. And this follows for both the homogeneous system or the non-homogeneous system. If we have the homogeneous system, then we will go for consistent only. If we have a non-homogeneous system, then we can see for consistent or inconsistent, whatever we have in the system. Okay, so the consistent system will have a solution. Solution exists. Or the inconsistent system, no solution exists. The solution exists or no solution exists. When the solution exists, how we know that the solution exists, how we know that the system is consistent? We have our matrix A, and we also have the matrix that is augmented matrix. We know what is an augmented matrix. When the rank of matrix A is equal to the rank of the augmented matrix is mentioned as AB. Augmented matrix is that one in which we have, suppose this is our entries in a matrix 1 2 3, it is a 3 by 3. In the last column we have the right hand side also. This is our augmented matrix AB. Okay, so when the rank of A is equals to the rank of B, the solution exists and the system is consistent. When the rank is not equal to the rank of AB, rank of A is not equal to the rank of AB, then there is no solution and the system is inconsistent. Now, if the solution exists, it can be unique or it might be infinite. Unique solution or infinite solution. If this unique solution is 0, the unknown variables have the answer 0, then this is a trivial solution. If the unique solution is 0, this is a trivial solution. If it is infinite, then it is non-trivial. Non-trivial solution. When is it unique? When is it infinite? When the rank of the matrix is equals to the number of variables. The system has a trivial solution, it has a unique solution. When the rank is not equal to the number of variables, not equal to the number of variables. When the rank is not equal to the number of variables, then we have a non-trivial solution, an infinite solution. And in such a case, when the rank is equal to the number of variables, when we have the rank is equals to the number of variable, the system is linearly independent. And when we have the rank that is not equal to the number of variables, then we have the system which is linearly dependent. So Here we see that what is a linear system, what are the types of a linear system, and how we mention it using the matrix notation, and then we see what could be the solutions of the system. So here it is easy for you with this chart. You can find out what type of system you have and whatever is the solution. Thank you so much for watching the video. Please do subscribe my channel. Thank you.